Welcome to Sangam tutorials, SP Gubbi online classes for 10th standard, Ncert and CBSE for mathematics and science classes. Right. So in the last session of lenses, that is physics, we had discussed a lot of points about terminologies connected to the lenses. So among them, one is the principal axis, then the principal focus, optic center, focal length, principal foci, first principal focus, second principal focus, and aperture of the lens. So these are the points discussed in the previous class. Very important terminologies. If you are well aware of that, this class you will understand. You will understand without any doubts. So before watching this video, if you have not learned the definitions, please stop the video, go back to the previous video, watch it again, once again, and then come back to this video. So in today's session, we will be going with certain rules involved in the formation of images by convex lenses. So I am going to discuss 3 rules here. So then we will go with the 6 beautiful ray diagrams where you are going to see how the images are formed in convex lenses when the object is placed in front of the lens at different positions. Right. So regarding convex lenses, it is going to form both the type of images, that is, it is going to form real and inverted images, as well as it is going to form the virtual images also. So these ray diagrams I am going to present it in front of you. So this will be a beautiful class. So you have to practice the ray diagrams. So write all the ray diagrams with the nature, size and position of the image and send it to the WhatsApp group. Do it as a homework today. Right. So we know what is a convex lens. So we are aware of it. Right. So here a convex lens looks like this, where it has 2 refracting surfaces, where both the refracting surfaces are spherical in nature, and this lens is thick at the center and it is thin at the edges. Such type of lenses are called as convex lenses. Right. So here this is the line connecting the center of curvature of the 2 spherical spheres, and this is the optic center. Right. So here rule number 1. So you should remember the rules before drawing the ray diagrams. You should remember the rules. So there are 3 rules here. So all the 3 rules I am going to show you now. You have to remember this while drawing ray diagrams. It will be easy for you. Right. So rule number 1. In case of a convex lens, if a ray is traveling parallel to the principal axis, so okay, this is taken F1 and this is F2. Okay. So the light ray, after traveling parallel to the principal axis, after refraction in the lens, it is going to pass through the principal focus. This is what happens in a convex lens. If a light ray travels parallel, or if a light ray traveling parallel to the principal axis is incident on the lens, after refraction, the refracted light ray is going to pass through the principal focus. So in case of a concave lens, so we know what is a concave lens. We have learned it yesterday. Right. So this is a concave lens. This is the optic center. So this is the line passing through the optic center. That is, this is F2 and this is F1. That is the principal foci. First principal focus and second principal focus. So now, if a light ray traveling parallel to the principal axis, when it gets refracted through the concave lens, it is going to get deviated, because concave lenses are the diverging lenses. So this diverged light ray, as though it appears, it has started from the principal focus. So this is the rule number 1 you have to remember. So whenever a light ray traveling parallel to the principal axis and gets refracted by a convex lens, it is going to pass through the principal focus. Or if a light ray traveling parallel to the principal axis, when it meets the lens after getting refracted, it appears as though it is starting from the principal focus. This is rule number 1 you have to remember. So let us get into rule 2, which is very important. So now let us take a convex lens This is the principal axis passing through the two principal focus, that is F1 and F2, that is center of curvatures. So this is the optic center. So if a light ray is traveling directly through the optic center of the lens, the light ray is going to pass out of the lens undeviated. This is very important. In the yesterday's class, while defining the optic center of the lens, I had discussed this. So this becomes the definition for the optic center also. So if a light ray, if it passes through the lens undeviated, then that point on the lens is known as the optic center of the lens. So the rule applies for convex lens. If a light ray is traveling through the optic center of the lens, then it passes through the lens undeviated. So the same thing happens in case of a concave lens also. So this is a concave lens. This is the optic center. Let us take it as the principal axis. This is F2. This is F1. So if a light ray is traveling exactly through the optic center of the lens, then it is going to pass through the lens undeviated. So this is rule number 2. Very, very, very important. Now, so here, keeping these two rules in your mind, you can draw the ray diagrams, that is image formation for both the lenses, that is convex lens as well as the concave lenses. So in today's class we will be going with only convex lenses. In tomorrow's session I will be going with concave lens. Right. So let us get into the ray diagrams. Right. So let us begin with at infinity. So when the object is kept at infinity with respect to the convex lens, how the image is formed in the convex lens, let us see that. So this is a convex lens. Let us take this as the convex lens. This is the optic center. This is the principal axis. This is F1, this is this is F2, this will be 2F1 and this will be 2F2. So the distance between the optic center and F2 will be the same distance from F2 to F2. So the distance between the optic center and F1 will be equal to the distance between F1 and 2F1. So this is, you have to get ready with this. So let if you are drawing some ray diagrams in your classwork book, maintain a distance of 2 centimeters, 2 centimeters, 2 centimeters and 2 centimeters. Draw a neat and clean convex lens. Right. So now the object is placed at infinity. The object is at infinity. Okay. So object is at infinity. So let us take two light rays which are traveling parallel to the principal axis. So this is a light ray traveling parallel to the principal axis to the lens. So according to rule 1, if a light ray is traveling parallel to the principal axis after refraction, it is going to pass through the principal focus. So let us take the second light ray. So the second light ray is also passing through the lens. It is going to get refracted at this point, and this light ray is going to pass through the principal focus. Right. So here, actually the two actual light rays after refraction are meeting at point F2. So therefore, let us write the characteristics of the image form. So image is at image is real and inverted. Image is real and inverted because actually two light rays are going to meet at this point. Therefore, at that point a real image is formed. Real images, as we know, they are always inverted. Okay. So now, what about the size of the image? The size of the image is highly diminished. Highly diminished. Highly diminished, or you can write it as point sized. Point sized. So it is formed at F2. So this is very important. So when the object is placed at infinity in front of a convex mirror, the image will be formed at f2, and that image is real and inverted, it is highly diminished, or it is point size and it is formed at f2. So this is what happens when the image is placed at infinity. Now, we will bring this object a little bit towards the lens, little bit. We'll bring it, let's see what happens here. So let us take it as beyond 2f1. Let us take it as beyond 2f1. That is after 2f1, but not to infinity. It is beyond 2f1. Just back of 2f1. So let us take the lens. This is a convex lens. Okay. This is the optic center. Let us draw the principal axis. This is the principal axis here. This is f1. This is 2f1. Okay. This is f2. This is 2f2. Right. So now this is the optic center. Now the object is kept beyond 2f1. That is, the object is somewhere here. That is beyond 2f1. Somewhere here. So let us call it as object AB. So let us take two light rays starting from it. So one we will take it as one ray, we will take it parallel to the principal axis. Exactly, we will make the light ray to travel parallel to the principal axis. So at this point it is going to get refracted and it is going to pass through, that is f2. Pass through f2. So this is the part of the light ray which is traveling parallel to the principal axis. Okay. Now let us take another light ray which is passing through the optic center of the lens itself. So from this point A, we will take another light ray which is passing through the optic center. So this is passing through the optic center. So here the light rays continue and the image is formed at this point. So if it is okay, 2f2, the image is formed at this point. The image is formed at this point. This is A dash and this is B dash. So image is formed between f2 and 2f2. So this is what happens. So let us see the size of the image here. So it is okay, nature of the image or the position of the image first. So it is in between f2 and 2f2. Between f2 and 2f2, the image is formed. So when compared to the size of the object, the size of the image is little bit diminished. So it is diminished, and actually the two light rays, are going to meet at this point. So therefore the image formed at the point is a real image, and the real image is always inverted. So it is real and inverted. Real and inverted. So what is the use of these lenses? Where these type of that is convex lens is used? That is, it is used in telescopes. That is particularly astronomical telescope. This is astronomical telescopes. This type of say system is used. So this is used in cameras. So this way of making the images is being used in cameras. So next we will go with another one. Let us bring the object still further. That is, let us keep it at 2f1. So let's see what happens here. So it is at 2f1. So let us keep the object at 2f1 and see how the image is formed. So now let us take a convex lens, right? So this is the principal axis, this is the optic center, this is f1, this is 2f1, this is f2, and this is 2f2. So these are the basic things. Now the object is kept exactly at 2f1. So let us keep the object exactly at 2f1 here. Exactly at 2f1, let us take it as A and B. So now, as usual, we will take two light rays from point A, where one light ray will be passing parallel to the principal axis, optic center of the lens, right? So the light ray from A is passing parallel to the principal axis, exactly parallel to the principal axis. After refraction, according to rule 1, it should pass through the principal focus. Okay, so it is passing through the principal focus C, right? So now we will take another light ray which is passing through the same optic center of the lens, which is starting from point A. So this is the light ray passing through the optic center. So exactly the image is formed here. So if you write this 2F2 over here, so for better understanding, so the image is formed at this point. At this point, that is exactly at 2F2. So if you keep the object at 2F1, the image will be formed at 2F2. So image is at 2F2, image is formed at 2F2. So what is the size of the image? When you compare with the size of the image with the size of the object, so we get the exact size of the object, that is same size. Same size, okay. So then then it is real and inverted. Real and inverted, because actually the two light rays after refraction are going to meet at this point. Therefore, the images are real and inverted. So it is at F2, same size, real and inverted. So where we are going to use this type of system in optical instruments? We are going to use this in terrestrial telescopes. Terrestrial telescopes. So these are the first three ray diagrams for the convex lenses. So let us recapitulate. So if we keep the object at infinity, the image is real and inverted, which is formed here. That is at F2. It is highly diminished, that is point size. So this type of system in optical instruments that is used in astronomical telescopes. So if you keep the object beyond 2F1, image is formed between F2 and 2F2. So it is diminished, real and inverted. So it is used in cameras. This setting of lenses are used in cameras. Okay. Next is 2F1. If you keep the object exactly at 2F1, the image is exactly formed at 2F2, which is of same size, real and inverted. So this system of using the lenses are used in the astronomical instruments like terrestrial telescopes. Okay. So we'll go with the next three ray diagrams connected to convex lenses. Okay. So at infinity is over. Let us now take the object still more towards the lens. Still more towards the lens. So now it is in between F, that is 2F1 and F1. Between 2F1 and F1, let's see what happens here. So this is a convex lens. This is the principal axis. This is the optic center. This is F1 and this is 2F1. This is F2 and this is 2F2. Now, I am going to keep the object between 2F1 and F1. So somewhere here. Between F1 and 2F1, I am going to keep the object. So let's see where the image is formed, how the image is formed. So let us usually take one light ray starting from the point A, which is traveling parallel to the principal axis. So let us take this light ray which is traveling parallel to the principal axis. So according to rule 1, after refraction the light ray should pass through the principal focus. It should pass through the principal focus like this. Yes, the light ray has passed through the principal focus. So let us drag it further, right, little bit further, right. So next we will take the light ray from point A through the optic center. So if the light ray passes through the optic center, then it is going to move on undeviated. So if you produce this principal axis, the light rays are going to meet at this particular point. So image is formed here, that is A dash and B dash. So image is formed there. So as you are bringing the object nearer and nearer to the lenses, the object is going away from the lenses, becoming more bigger and bigger, right? So here we can write the consequences. So what is the position of the image form? The position is beyond. The image is formed beyond 2f2. So the image is real and inverted because actually the two light rays are hitting at that point. So here the image is enlarged. So when compared to the size of the object, the size of the image is highly enlarged. So it is enlarged. Enlarged is enough. So now let us get to the next one. So we will bring the object and keep it on F1. Let's see what happens. So at F1. At F1 we are going to place the object. So let us take the lens. So this is a convex lens. So this is the principal axis. This is the optic center, that is F1. This is 2F1. This is F2 and this is 2F2. Now let us keep the object exactly at F1. Let's see what happens here. Exactly at F1. So here let us call it as the object as AB. So let us start one light ray from point A, which is parallel to the principal axis. Same thing for every ray diagram. So it is traveling parallel to the principal axis. So after refraction, according to rule 1, you should pass through the principal focus and move on. Right. Now let us pass the second light ray from point A through the optic center. Same thing, no changes. So let us make it to pass through the optic center. So here the light ray is traveling and traveling and traveling, right, where the two light rays are exactly traveling parallel to each other. They are exactly traveling parallel to each other. So here the two light rays will never meet each other, but we assume that these two light rays which are traveling parallel to each other after a very long time, long distance, they meet at infinity. So these two light rays, they meet at infinity. For example, if you take this point as infinity, then this is the principal axis and this will be the image form. For example, you should not write this. What I will do, you should not write this. For your understanding, I am writing this. This point is infinity, then here is the object form. So here the size of the object is highly enlarged when compared to that of the object. So let us write the statistics. So image is formed at infinity. Image is formed at infinity. Then it is highly enlarged. It is highly enlarged, and at infinity also, as the two actual light rays are going to meet, the image is real and inverted. Real and inverted. So the image is formed at infinity, it is highly enlarged, so it is real and inverted, right? So here, what is the use of the object keeping between 2F1 and F1, where in which particular optical instrument this setup is used? So it is used in cinema projectors. This adjustment or this phenomenon is used in cinema projectors. So where this phenomenon is used? So this phenomenon is particularly used in searchlights. Right. So for every ancient ray diagram, you should know how to write the ray diagram. You should be able to write the images, everything connected to the this particular position of the image, that is position of the object and image formation, and also one use of this setup which is used in particular optical instrument. So let us get into the last ray diagram, that is the sixth ray diagram, which is very important. Okay, now So we had kept the object at exactly at F1, so the image was formed at infinity, it was highly enlarged and it was really inverted. So let us move the object still more further towards the lens and keep the object in between F1 and optic center. So when the object is kept between F1 and optic center, F1 and optic center. Right, so very important. Let us draw the lens. So this is the convex lens. So here this becomes the principal axis. This is the optic center. This is F2, and this is 2F2. This is F1. At the same distance, it is 2F1. Okay. Now let us keep the object in between F1 and the optic center. So this is A and B. Now, usually what happens is one light ray we are going to take it from the optic center directly. That is parallel to the principal axis first. So the light ray is going to travel parallel to the principal axis. So according to rule 1, after refraction, the light ray has to pass through principal axis. Principal focus. So this is what happens. So now let us take another light ray which is passing through the optic center, right? So let us take this light ray passing through the optic center here. So the light ray starts going here through the lens undeviated. So these two light rays, when we compare each other, they are diverging light rays. So both the light rays are, you can see here, they are diverging. Diverging light rays in the sense they will never meet each other. So when they are produced to until infinity, they will never meet each other. So then we cannot come to a conclusion that when the object is placed between F1 and optic center, the image is not at all formed. So in this case also the image is formed. So here to frame the image, we are going to draw the two lines backwards. We are going to draw the lines which are starting from A and B backwards. So when we draw these two lines backwards, they appear to start from a point somewhere here. So here we say that the image is formed. So this is the image formed. So it is A dash and this is B dash. So it's we can say that it's a virtual image. So virtual image because this image is not formed by actually the two light rays meeting, but it appears as though image is formed at this point between 2F1 and F1. So between 2F1 and F1 the image is formed. So it is virtual and erect. It is virtual and erect. So it is enlarged. When compared to the object, the size of the image is enlarged. So here, this particular optical phenomenon, what's happening when the object is placed between the optic center and principal focus. So this phenomenon of optics is used in microscopes. It is used in microscopes. Right. So these are all the types of image formations in case of a convex lens. So all the 6 ray diagrams with 3 rules I have explained you. So with all the uses of each and every one. So you have to remember this very carefully. You have to practice this ray diagrams by observing the position of the object and position of the image every time, because in case of numericals, when you read the problem itself, you should come to know where the object is formed and where the object is kept and where the image is formed, and how we can calculate the remaining things, right? So if you want a clear-cut idea for numericals, please practice these ray diagrams and understand these positions and uses of each and every ray diagram, right? So I hope you enjoyed the entire session of the ray diagrams for convex lenses. So in the next class I will be getting into the relation between F2 and V, including 2 ray diagrams for concave, that is lenses, right? So practice the ray diagrams and please understand how the rays are is they come up how the that is images are formed, right? So already today's date, 10th is over, so I have given you the last date for the payment of fees. So please pay the fees and see that the classes go on very smoothly. So stay home, stay safe, keep learning. Thank you.